In this video, we are going to solve problem 5.1. First you try. If you are not able to solve the problem, then you can see the full video. First we read the problem, then we will solve the problem. A particle of charge Q enters a region of uniform magnetic field B pointing into the page. So magnetic field is pointing into the page. So we represent the magnetic field by cross sign. If magnetic field point into the page, then it can be represented by a cross sign. Okay, so we represent a magnetic field by cross sign. The field deflects the particle a distance d above the original line. So the particle is coming as along the dotted line, but due to magnetic field it is deflected by a distance d. Is the charge positive or negative? So first it is asked in the question that charge is positive or negative, and other part is that we have to find the momentum of the particle in terms of a, d, b and q. Let us first assume the coordinate system. So this is our coordinate system, that is x cap, y cap and z cap. So the magnetic field direction is, if we write magnetic field in a vector form, then v vector is equal to b minus x cap, because it is pointing into the page. And velocity, if we write velocity in the vector form, then v is equal to v y cap. And the force is acting in the z direction. If we see, force is acting in the z direction because it is deflecting in the z direction by a distance d. So first we assume the charge is positive, and if our assumption is correct, then the force should come in z direction. If our assumption is incorrect, that means the charge was negative, then force will come in minus z direction. So we can say according to the force direction. So first we assume charge is positive. So we know that F vector is equal to Q V cross B. So F vector will be is equal to Q, and V is V by cap, and B is a B minus X cap. So V and B will be out of cross product, then QVB and minus also will be out of cross product. So F vector is equal to minus QVB by cross X. So Y cross X, we know that Y cross X will be minus Z. So F vector is equal to QVB Z cap. So the force is coming in Z direction. It means our assumption is right. The charge will be positive. If it comes minus Z cap, then the charge will be negative. Now let's move ahead for the second part. We have to find the momentum. So we know that from the cyclotron formula, that R is equal to mv upon qv, and we know that mv is a momentum. So mv is equal to qbr. We have to represent the formula in terms of qbad, but we found the formula in qbr, so we have to replace r. So how we will find the r? Let's say this is the center of that arc. So this will be the r, and from this to this will also be r. But we have given this distance is a and this is d. So this distance will be r minus d, and this will be r. So let's say this is O, this is A and this is B. So in triangle OAB, we will apply Pythagoras theorem. So r minus d ka whole square plus a square is equal to r square. So r square minus के r minus के d का whole square is equal to a square. So r minus के r plus d twice r minus के d is equal to a square. So from here r will be a square plus d square upon k twice d. We can plug this value in this equation. So mb is equal to qb and r value we have found. So a square plus d square upon twice d. So that is the our momentum.